Alright, hello, welcome back to Digital Drafting and Design. This lecture is going to kick off section 1, which is going to cover CAD fundamentals. So we're going to have 4 different lectures in section 1. Those lectures are going to cover the history of drafting and the emergence of CAD, the basics of two-dimensional drafting, points, lines, polygons, basics of three-dimensional drafting, isometric objects, surfaces, volumetrics, and then lecture 4 will cover creating a template in CAD. So let's go ahead and get started with lecture 1. So lecture 1, as I said before, is going to be the history of drafting. And this is going to probably be the most textbook portion of the course, where we're going to start going over just kind of how we got to where drafting is today, kind of where it comes from, where it stems from, and the deep ties it really does have to land surveying. So going back about as far as 8000 BC, we've found, not we, but archaeologists have uncovered detailed engravings that reveal blueprints of desert kites. And what desert kites are, it's a topographic feature of kind of two high points over a sunken area. Imagine like a meteor crater site with kind of two raised sections on either side. And those were discovered, and those exist all over the world, but the kind of two-scale replicas of these desert kites that we found were in locations in Jordan and Syria. So kind of close to the bedrock of civilization as far as we know today. And what these blueprints revealed, based on what other findings that the archaeologists found along with the blueprints, was that they were utilized primarily by hunters to try to create replicas of a hunting pattern to essentially where to drive animals into, where they need to set up from in order to kind of corral them, and then how to more safely then take down their prey. And I know that sounds like hunting, not necessarily drafting or land surveying, but if you think about it, what the point of it is, drafting is intended to represent, create visualizations of topography or intended designs on existing topography. And that's how it has the ties then to land surveying. The purpose of land surveying is to capture, detailed copies of the world, to measure the world, measure the earth. And for what purpose is that? Well, any anthropogenic purpose is really the reason. And if you think about the most important of all anthropogenic impacts that we have, it is going to be hunting and gathering. So going back to the absolute base needs of humanity's survival, people were surveying, in very rudimentary ways, and drafting in very novel ways, carving into sandstone. So that's kind of an interesting way to think about it. And when you try to think about anything that you're doing when you're drafting and you're trying to recreate or visualize your surveys, understand like that's the purpose, not hunting, but recreating that environment for whatever your intended project is, creating a visualization of that area so that it can be utilized by engineers, architects, designers, whatever, to kind of see their projects come to fruition. And then with society comes the surveyor, and this is where we kind of stay in the same area, where kind of the Babylonian Empire or Mesopotamia, modern day Iraq, we started to see, instead of just carvings on walls, we started seeing tablet recordings, more unique diagrams, certain types of circle maps or TNO maps being created to try to create replicas of the world around them. And I know you might be thinking, hey, that's a map, not necessarily a drafting product, but that's kind of the drafting that we think of today, or the maps of yesterday. Drafting is possible because of the technology and the advances that we've had in different types of writing materials and pens and pencils and yada, 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 and now computers. Before, when you're working just with tablets made out of clay, you're going to have to kind of look at things at a larger aerial view. So that's where it really started. And these are considered to be the oldest recorded blueprints, not necessarily just replications of what they're seeing, but actual blueprints putting survey information onto a medium and then dispersing it for use. And a lot of these blueprints by the Sumerians were used, and it showed a lot of advancements culturally or among their societies, both in writing, the ideal of record keeping, which is a huge part of land surveying. I mean, it's probably been drilled into you time and time again. Those field books, those are legal records. They're required by law to be stored in a fireproof safe. If your house burns down and you lose all your records, you're liable for that. If you can't prove that you properly stored them, now we have digital record keepings. We look at different types of cadastre that exist. You look at the central appraisal districts and all the information that's stored there. And we also saw a lot of advancements in utilizations of mathematics. All right, we're not just counting the number of bushels anymore. We're actually recording measurements between land features, measurements between buildings, so that we can do site planning, so that we can start designing towns, or urban design, urban planning. And that was one of the major uses of surveyors and drafters kind of in these times. And of course, in these times, you're not called surveyors, you're not called drafters. Everyone is just considered a philosopher, in this day and age. So that's what all these people were, and we're the modern day philosophers, just a little bit more focused and with a little bit more technology. Then, moving forward, this might be familiar to some of you if you've been working in land surveying for a period of time, but kind of our pre-digital revolution, which still existed for quite a while, post-digital revolution. But drafting was done in essentially workshops. You had large teams of drafters, whether they're young engineers or surveyors, or just, mathematicians dedicated to it, working on creating our blueprints by hand. If this was an in-person class, I think we'd have some exercises working with different, templates and protractors and French curves, and getting to kind of draw a lot of your own things out. Think about that kind of stuff in your surveying classes and your field books when you're doing your site sketches. Don't just scribble the quickest lines you can down. Put a little pride into that. And with time, you're going to start seeing a lot more detail come in your work. And then the more detail you're able to put in your physical sketches, you're going to start replicating that in your drawings as you start to master the software. And then you start getting more and more detailed and accurate and useful products. But again, pre-digital drafting took a lot of meticulous record keeping. You have to imagine one error, and most of this work's done in pen. You got to scrap the whole thing. You talk about a change request. You can't just open up your blueprint and highlight an area, remove it, put your little bubble in, and draw the changes. No, you've got to start over. You've got to do a lot of tracing to get the exact replica of what you had, and then add the changes that you're making to that. It was a very, very detailed and very, very laborious process. And to some people, this might have been considered the golden age for land surveying and for drafting, because the size team that was required to kind of conduct a lot of these projects, created such a demand from the labor force to do all of this. Looking here just at this image, you see, dozens of drafters in there working, and that could probably all be done by one person today, which is amazing to think about. And I think that's where, all of you being here today is going to be useful, not just here in this class, but here in this program, working on getting your degree and pushing for your license. It's going to be necessary, because it's going to be a lot more competitive in certain areas, because you can do so much with such little manpower. Fortunately, for all of you as well, we haven't seen a lot of people get into this profession. So right now, it's a good time for you to get in, learn all the technology, learn how to do these things, not just the way it's currently done, but how it has been done, because again, surveying requires you to follow the footsteps of the previous surveyor. So you are going to have to, not the previous, but the original surveyor, so you're going to have to learn how they did everything. You're going to have to then apply it to today's technology, and then from there you'll be able to market yourself, I think, to a lot more a broader audience. Whether you're trying to go engineering, or you want to work in civil construction, or you want to be just a true boundary surveyor, those are all things that are going to be useful to you. And then we came into the digital revolution, and that's where we are now. So, and it's been going on kind of since the 50s and 70s is really when we saw some of those major jumps in technology. And then throughout the 90s, some people like to say, Y2K was the end of the digital revolution, and from there we've entered the information age. But in reality, the digital revolution is almost just a subset of the information age in which we currently exist. And I think at the same time where we saw a lot of drop-off in the amount of manpower that it used to take to conduct a product, the amount of oversight and due diligence and attention to detail, technology stole some of that from us. Everything got fast. Everybody went from taking your time, checking your work, ensuring everything's perfect, because it's a lot of work to do anything over again once it's been committed to pin. And now, Control C, Control V, Control Z, and just keep going. It's not a big deal. I made a mistake. Let's start over. There was a drop off in a lot of quality. And that's something that we're working back from right now. Everything became too easy in some ways to do, which means it became even easier to make a mistake and, not have the proper oversight to catch it. So it really does become the responsibility of the individual, and you eventually, as all being RPLSs or GISPs, it's going to be important that you take full custody of your work, from the field book to the drafting designs to the rubber stamp, and if you're on the GIS side, full custody of all of your data, managing your own databases, and ensuring your products are using accurate and relevant information, not misrepresenting things, having appropriate disclaimers for your work. All of that, it's a lot of checks that you have to now put on yourself. And as you progress throughout this course, you're going to learn a lot of the responsibilities, the things that are going to be expected of you to do as a professional. And then in things like legal aspects, in your boundary classes and your field camps, you're going to start learning a lot more of how much of it's on you. You're not going to have necessarily someone standing over your shoulder checking them. And in surveying, it's that ideal of responsible charge. If you're interested in getting licensed, you can't have someone holding your hand the whole way. They're going to expect you to have the knowledge, and the know-how to check your own work, to ensure that, what you're putting together, the products that you're putting together, are complete and accurate representations, as intended by your clients. So there's things to really keep in mind. I don't think that's a novel ideal for anyone here, that, technology in some ways, they say make us dumber. It's not really dumber. It's just made us a bit more hasty in some of our decisions. Sometimes slowing down and putting thoughts into the work that you're doing is going to be vital for your career, because one major mistake is something, especially in surveying, that can follow you, for quite a ways. So you want to make sure that you're on top of your work and you know what you're doing. And hopefully by the end of this course, you're going to feel a lot more competent and comfortable in your CAD capabilities. So we're going to go into a little bit of kind of the idea of what is survey drafting. Survey drafting, by definition, is going to be the process of creating an accurate drawing to scale, showing the results of a survey, delineating all pertinent information, including existing, proposed, and adjoining property lines. So that's a nice definition, but what does it mean? So first of all, we're talking about the results of a survey delineating all pertinent information. Pertinent is a key word there. Um, Pertinent, being defined as appropriate, related, or applicable, is essentially going to be saying what's the project, what's the intent of the survey, what are the things in this, that I'm going to need to capture. So if you're trying to do a site survey and a construction crew is going to come out and they're going to bulldoze everything, pertinent information, you're going to be talking about, hey, I need to see trees. Anywhere I see concrete, we're going to need to identify that. If there are particular concerns of pipelines or water lines, if there are utility poles out there, that's the kind of pertinent information that's going to be really relevant. Do I need to know where every shrub is? Do I need to, identify small batches of trash in an area? Maybe not. But then take a flip side of something more, demanding. Say you're trying to do a site survey for, the campus for Texas A&M University, Corpus Christi. What are the kinds of things that are going to be pertinent that you capture, in your drawing there? Well, we're going to want parking lots, we're going to want sports fields, we're going to need all of our buildings, any, visible utilities we're going to want to capture. All of that is kind of information where it gets a little bit more detailed. Maybe they are going to be interested in every single bush. Maybe they need to use site plans to identify landscaping contracts. So what are the areas of all my green spaces? I need to know the boundaries for those. I need to know how many trees do we have, what kinds of trees do we have. All of that information is stuff that can be collected and identified, in your drawings. So and then beyond that, past our pertinent information that we've now looked at, so we'll go into more the ideal of a boundary survey and talk about existing, proposed, and adjoining property lines. I know some people like to talk about the four-corner rule in surveying, and essentially the ideal is that you are only trying to identify objects that are on the four corners of that original survey. Anything else beyond that is irrelevant to you. And in some instances that may be true, but I don't really like the four corner rule, and the purpose and the reason for that is because not all surveys are created equal. There are good surveys and there are bad surveys. If we have an original survey that doesn't identify any adjoining property lines, or if we have it's supposed to be a subdivision design, but it doesn't show where any of the lots and blocks are, or if you just have one section and it's disconnected from everything else, we don't have accurate representations of the information that we need in order to properly and accurately draw to scale, and show the results of the survey delineating all that pertinent information. So those are things to think about there. If you're just the drafter and you're not the guy that was in the field, and we don't have adjoining properties, we haven't have adjoining monuments to tie those in to try to help hold true the monumentation we found for our property, then you're missing information. You have not collected enough. But at the same time, as a third example here, we could say, hey, I've thought about property lines, I've looked at the boundaries here, but in reality, my client, they just need a topo. They need a topo map, provided to them, or in these days, probably just a data set, not necessarily a map, but a data set of this area, something that I can slap into Google Earth. I need a KML to show my clients. Well, maybe you don't need to identify all of the structures, all of the trees, or all of the property lines or utility. Maybe they really just care about the surface, depending on what their study is. Excuse me. That's where maybe you're going to have to say, hey, I'm trying to draw this, but I don't have, equal distributions of points, or, I have a rough idea of what this terrain looks like, but I don't have, tight enough points around maybe some of my cliff faces. And you can kind of see an idea of what I'm talking about with cliff faces kind of here on this tint model. It's representing the topography. So these are real tight. This is showing there's a steep change in height, coming with a high point here, down low here, and this is a bit, gentler of a slope. and this being a bit more medium. That's the kind of stuff that is going to be important to capture. And if you have a general idea of what a site's supposed to look like, and you should, when you're putting these together, you should quickly be able to tell if the appropriate amount of data has been collected. So it's a big part of drafting, of the visualization of these data, is truly and properly understanding how information and how land should be visualized. Two other notes and a bit more specific, moving on from the ideals of what is survey drafting. Important to note for all of you that are going to go into the survey route, that survey drafting, and this is going to be pertaining primarily to boundary, does fall under the definition of professional surveying in the state of Texas. It's part of the Texas Occupation Code. Drafting is a responsibility of a RPLS. So take that in mind when you think about the quality of work that's going to be expected of you. As a SIT, a future RPLS, LSLS, you are providing professional grade work. You're not creating, I've slapped some stuff together and I've handed it off to the RPLS and they'll make sure it's good. No, you're responsibly charged with providing those accurate drawings. It falls under that, and that's why all of your work, your office work as it's often called, or the drafting work, counts towards your hours for your license. And under that same Texas Occupation Code reference, going into what I was saying, the task of drafting is often a delegated responsible charge that's going to be given to a surveyor in training. So you should expect, upon graduating from this course or this program, being able to take your SIT right away and then start requesting that responsible charge. And I think that's important, especially for some of you that are younger and maybe don't know the industry as well. Be clear you want to be given responsible charge. Don't just be, hey, this is what you're going to do. Be like, yes, I want responsible charge. Please give me responsible charge. I want my hours. I want to work towards my license. Because that's something that you should all be aiming for if you're in this course or in this program, is your RPLS. That should be your end goal. And if it's not, or if they're not willing to give you that responsible charge and sign off on it, you need to be aware that that's going to be a hindrance to your career towards becoming a professional surveyor. So getting into a little bit more then about computer-aided design, or CAD, not just survey drafting, but CAD really is, it's the technology that advances the capabilities, precision, efficiency, and ease of use for drafting tasks. It's going to, like we said before, it's going to allow drafters to create, modify, analyze, and visualize their survey data on the fly with easily undoable steps. So you can start on something, work part of the way towards completing it, decide, what, I really don't like the way this is going, I want to approach it differently, and it's very easy to go back, start over at a certain point, and then start going forward again. It gives you the ability to, in real time, get to assess that survey data, because you're going to be loading in your survey points already. You're going to have codes attached to those points. You're going to be able to look at all of that information, whether you're using keys or field to finish processes. It's going to let you kind of see what it can look like and allow you to adjust again on the fly. So with CAD, there are two primary forms of drafting that you need to think about. One is 2D drafting, and the other, obviously, 3D modeling. 2D drafting is going to be talking about creating Cartesian visualizations of the real world. Again, using orthogonal views to convey topography. If you've already taken your GIS 1 class, you know exactly what I'm talking about there, but I'll go back up real quick to that digital revolution slide. In this is two-dimensional drafting. Even though you can see along these roads, we have elevation markers, we have changes that are being recorded throughout as you progress through. We're still looking at that orthogonally or two-dimensionally. It's the Cartesian format. And then talking about 3D modeling, That's where we're talking about creating, the three-dimensional visualizations of the real world. I like to say modeling instead of drafting because it's really not something that's drafted. It is a model. You're creating a model of the area, the data that you've collected. It's going to allow more immersive visualizations. So when you start looking at like those LiDAR data sets and those visualizations, that's really allowing you to immersively get in there and see the real world within this CAD environment. That's going to allow you to analyze things differently because you can see kind of the impacts, whether we're looking at flood modeling or if we're talking about, cut and fills. You can directly see, it's like, that sounds like a lot of dirt. Let me look at it. You can see it. You're talking about volumetrics if you're doing surveys for ports, whether it's ocean ports or train ports. That's a common thing that surveyors have to do, whether they're collecting it, on the ground or more commonly these days with drones or UASs. Again, you can visualize how much stock you have there, on those sites that can then be used to kind of understand, okay, how much more can we fit? Let me try to survey out more sites. Where can we fit them? Show me on a site plan, things like that. And again, more and more these days, a lot more than when I was actively surveying. 3D modeling is becoming more commonplace in the AEC industry. Again, specifically because of things like LiDAR, radar, and sonar. LiDAR, especially for terrestrial observations. And then again, sonar and radar technologies are still huge in the hydrographic surveying world. It'd be really cool if you'll have the opportunity to take a hydrographic surveying class as an elective at some point during this program. I wish that for y'all. All right, moving on to our last part, talking about industry standards. And this is something that I just kind of wanted to give a brief overview of, specifically because a lot of standards that are in place now, if you're talking about drafting that you're going to be doing, if you have to focus on industry standards, you're going to be working for much larger firms that aren't just survey firms or engineering firms. They're going to be construction or oil and gas companies, and they're going to have their own internal standards. They're going to have their own industry regulations that have to be taken into consideration. But overall, as a basic, our three most common kind of industry standards that you can take a look at, and if we have time towards the end of the semester, maybe we'll delve into a little bit more, is ANSI, ISO, and DIN. ANSI being the American National Standards Institute. So again, it's a private nonprofit organization. It's going to oversee the development of voluntary consensus standards for various industries in the United States. So they're going to be looking at things, engineering, architecture, manufacturing, and surveying as well. And again, it's going to be specifically in the context of drafting, where we're going to be looking at these things. It's going to have specific rules regarding dimensioning, tolerances that are allowed, symbols, line types, and other aspects of technical drawings. And just to specifically talk about tolerancing and dimensioning, it's one of those things that I think a lot of young surveyors or young drafters make a mistake of doing. And you'll import your survey data and you'll have measurements that are created within the CAD. It does a lot of the math for you. You simply have to know how to use the tools. And because it's a computer, it can go to however many decimal places you need. Now, if you put 15 decimal points on your Latin long for a benchmark on a survey in your drafting product and stamp that, you're claiming that's how accurate your measurement is, based to that tiny, truly unmeasurable point. That's not even going to be within the tolerance or the accuracy of your equipment that's used to collect it. So understanding significant digits, understanding, where you should be setting your decimal places to is going to be important for you as a professional, because you will almost certainly have your drawings pulled up, in a TSPS seminar, talking about bad maps. It's something that they do annually, and you don't want to be that person. So that's something we'll talk about maybe a little bit when we do dimensioning on any of our lab exercises, but it's something to also take into consideration when you're filling out your field books for plane measurement 1, plane measurement 2, or field camp. What is the accuracy of my equipment? How many decimal points can I truthfully say, this is measured to, and record that information. ISO is going to be a little bit bigger than ANSI, so it's going to go global. If you ever are working in the oil and gas realm, you're going to have to deal with a lot of ISO things. If you go the amazing route of becoming, a geodesist, ISO is going to be a lot more important than ANSI, because it's going to just be taking the same standards of ANSI but applying it. What's the standard globally? And then the Deutsches Institute of Nuremberg, that's the German standard, and why that one's in here specifically is because a lot of the geodetic work that's done globally is going to utilize that standard, just because they kind of lead the charge in geomatics. You'll see a lot of the survey equipment and a lot of the survey equipment companies that have been bought up by places like Trimble and Altera. Those are all originally, German or Swiss companies. They kind of set the bar when it comes to geomatics accuracies. So keep that in mind. Just in case, you're one of those people, it's like, I want to survey and travel the world. Those jobs do exist. I've done them, and they're amazing. Highly recommend it if you get that opportunity. But that's it for industry standards, and that kind of covers lecture 1. So now you can see we've gone over the history of drafting. On our next lecture, we're going to be talking a bit more technically, and we're going to get into two-dimensional drafting. So let me scroll back up to that. There we go. So again, our next lecture, which I'll have available for you by the end of next week, is going to cover the basics of two-dimensional drafting. All right, if you have questions, go ahead and send me emails at brian.gillis@tmucc.edu. We actually have access to Canvas now, and your course should be public, so you'll be able to find all this information on Canvas. These lecture videos, I'll put links to them on Canvas as well. I'll continue to update the data on the ArcGIS group that I had previously set up. So that's where you prefer to take a look at things. Go ahead. For your labs, again, you're going to be able to submit those on Canvas. As far as due dates are going to be concerned, Section 1 is going to be everything from Section 1. So these 4 lectures and the labs that are going to be associated with them, it'll be 3 labs, are all going to be due by midterms, by the end. So essentially at the end of spring break. This is a online asynchronous course, so I want to make sure you have time within your schedules to kind of get this stuff done. But again, I'm giving you a lot of rope here. Don't make the mistake of trying to put everything off until the very end. Make sure you try to stay on top of it when you can, where you can. And again, if you have questions, always feel free to reach out, especially if you're having any issues with software. That's going to become a lot more important going forward. All right, that's it. It's the end of lecture 1. See y'all next week.